Hello, assalamu alaikum, all viewers and dear candidates. Today we are going to learn about the sampling without replacement. The expected value of the mean of x bar is equal to population mean. We are using with replacement case. Let's come start. Show that expected value of x bar is equal to mean of x bar is equal to mean using without replacement case. Now, as we know that expected value of x bar is equal to summation x bar f of x bar. According to the definition, if we have used j is equal to 1 and here xj we used and also here we use j is equal to up to 1 to so on up to n term. Now as the case is without replacement, so we use the formula. As we know that all possible samples are without replacement case in combination n, and probability of each sample is 1 divided by n combination n. In case of this probability, we use the term here n combination n. So the term expected value of x bar is reduces in the form of summation n combination n j is equal to 1 and xij, and this probability of each sample is 1 divided by n combination n. Now we change this result here x according to the expected value summation x bar. X bar is equal to, we can write x bar is equal to summation x divided by n, and here 1 divided by n combination n we change to the here to the first, and summation j is equal to 1 up to n combination n, and xij we are using summation I is equal to 1 up to n xij. Now here n combination n is used, so we use the formula in replace of, as we know that the formula, we know that here we give the equation number first. We know that summation in case of with replacement xij is equal to n minus 1 combination n minus 1 summation n I is equal to 1. So this the whole term is equal to n minus 1 combination n minus 1 summation I is equal to 1 up to n xi. Now we replace this term, in replace of this term we put this result in equation number first, put in equation number first, expected value of x bar is equal to 1 divided by n combination n. In replace of this term, we put the value of n minus 1 combination n minus 1 combination n minus 1 summation I is equal to 1 up to n xi. Now we expand this term according to the combination n factorial divided by n factorial n minus n factorial n minus 1 factorial divided by n minus 1 factorial n minus 1 minus n plus 1. This will be changed here into plus summation I is equal to 1 up to n xi. Now we change this result, this will be changed to denominators. We can write this term n factorial n minus n factorial divided by n factorial and to n minus 1 factorial divided by n minus 1 factorial, and this plus 1 minus 1 are cancelled. Here we get n minus n factorial summation I is equal to 1 up to xi. Now what is the result? Both this term are cancelled to each other, both are same. Now expand this term up to n minus 1 term. We can write here n factorial n into n minus 1 factorial. Similarly, here n factorial and here n minus 1 factorial. We expand n factorial n into n minus 1 factorial. And here n minus 1 factorial divided by n minus 1 factorial. Summation I is equal to 1 up to n xi. N minus 1, n minus 1, n minus 1, n minus 1 both are cancelled, and here we and here we have missed one term here n, because we have already changed here. There is also n is present with these terms, also present with these terms as a whole is coming with the whole term. So we change this term n, and n is also finished, and here is also n is present, and here also n is present. There is missing this term, so and this term is n and n minus n factorial. Now both are cancelled. We get the last term summation ni is equal to 1 up to xi divided by n, which is mu. So expected value of x bar is equal to mean of x bar is equal to mean, which is verified. We have proved it about term. Thank you very much for watching. Appreciate you in advance. Please subscribe my channel.